Okay, good evening. So today we'll look at one problem from CS net of this year. The problem is actually lengthy if you go with solving it in a conventional way, but there's a way to kind of find a short solution to this, and I'll just uh, show you how to do this. So this is the problem. I'm sure all of you are aware of this. So basically a circuit is given, and this resistance here you put two different voltmeters of different resistances, and then it asks you to compare the voltage reading that you get from the two voltmeters. So what is that ratio, VA VB? So this is the circuit. One voltmeter has an internal resistance of 2 mega ohm. Second one has internal resistance of 0.1 kilo ohm. So you measure the voltage drop across this resistance with both of them, and you get your reading. So the ratio is what? So that's what you have to answer. Okay, so conventionally, so you will have okay. Before that, let me just say that once you see this kind of problem in the exam hall, you should be aware that the calculations can get lengthy, and it can be time consuming, and it's also possible that maybe at the end, since the calculations are long, you'll probably not get the right answer, or you will miss out some factor or something like that. So you have to be a little bit careful, and you have to always look about ways on how to solve it smartly. And what I also recommend is that these kind of problems you leave it for the end, when you don't have anything else to do and there is still time left, then you attempt that. Okay. So of course, this is a very simple problem. It's normally you will apply Kirchhoff's law and these two circuits, and you'll find the voltage drop and so on. And you do it two times. Once you put a 2 mega ohm resistance in parallel. Second time you put a 0.1 kilo ohm in parallel, and you apply all the Kirchhoff's law, everything, and then you find the final answer. Okay, so this can be lengthy, and it will be lengthy if you do it with conventional means. I'll just show you a slightly shorter way of doing it. Okay, so first of all, we start with this voltmeter, which has 2 mega ohm internal resistance. So this is the circuit for both of them. Once you put a 2 mega ohm resistance here, that resistance is very high as compared to a 100 ohm resistor, right? So most of the current will actually be flowing through this only, and the equivalent resistance will be very close to 100. So it's 100 into this divided by sum of these two. It's almost 100. So the equivalent circuit after you put the voltmeter will be same as the initial one. Okay, and instead of now using the Kirchhoff's law, you put two currents in two loops, or whatever way. You use the current analysis, and then you calculate the potential drop. Let me just try to look at it a little bit more simply. So what is the equivalent resistance here? This is 100, this is 200. It's in series, so that's 300. 300 connected to 150 in parallel. So what is the equivalent? So it will be 100. Yeah, why? Because if there is x and x by 2 in parallel, the equivalent will be x by 3. Yeah, so it's x into x by 2 over x plus x by 2. That will be x by 3. So this is equivalent to 100 ohm resistance here, these three. So there will be 100 ohm in series with another 100 ohms. So the voltage drop on this one will be 10 volts, and the voltage drop on this will be 10 volts. So the voltage drop across these 2 points will be 10 volts. So 10 volts will drop when you go through this. So if 10 volts is dropping, around two resistors in series, so voltage drop will be proportional to the value of resistance. So the voltage drop here will be half of here. So here it's 100 ohms, here is 200 ohms. So here if the voltage drop is X, here it will be 2X. So basically 10 volts is the overall drop. So 10 by 3 will drop on this, and two-third of 10. So 20 by 3 will drop on this. So VA is almost approximately equal to 10 by 3 volts. Okay, so this is what we can calculate without really applying any current analysis. Okay, and then we can do a similar thing here. So next time when you connect a 0.1 kilo ohm voltmeter in series, so that 0.1 kilo ohm is equal to 100 ohms basically. So you have 100 ohms, and then you have another 100 ohms in parallel. So net, this will be a 50 ohm overall. Yeah. So 50 ohm resistor, and then you again try to do the same thing. So it's 50 ohms, 200, 250, and then in parallel with 150. So the equivalent resistance would be 250 into 150 by this. And then when you calculate it, it's 375 by 4, and that's, you just put it approximately 100. Okay, so in this case also what happens is that the net resistance here is almost equal to 100, and there is 100 here. So 100, and that will be in series with another 100. So that means 20 volts is given, so 10 volt will drop here, 10 volt will drop here. So the drop across these 2 points will be 10 volts. So now, but here the difference is that this time there is a 50 ohm here and 200 ohms here. So voltage drop here will be 4 times of this. Okay, so it's 1 by 5 of 10 here and 4 by 5 of 10 here. So the voltage drop here would be 10 by 5. Okay, so it's 2 volts. So 2 volts will drop here. So the reading will show here 2 volts. And now you can easily calculate VA by VB. It's 5 by 3 approximately. And that comes to 1.7, and that is 1.73. So this is a short way to analyze such circuits and to solve such questions. And but I still recommend that whenever you see something, you should always be think about whether the problem will go lengthy or whether there is a short way to solve it. And I repeat that these problems, you keep it to the end. If you have time, then you go for it. Okay, so that was the problem for today. That's what I had to show you for today. And I also have a course for net. If you're interested, you can just send me a mail. Okay, otherwise, thanks for watching, and let's hope the net results will be out soon. Okay, thanks very much.